So we're back for the January 2016 Part 1s. We'll resume at number 13. So let's see. Okay, we're looking at similar figures. They're giving us kind of the corresponding angles. Okay, they're asking us to justify by side angle side. So if AB is 6 and AC is 8, we're going to need angle A congruent to angle D to get that included angle. These two are out. That won't work. Now, what we're trying to do is test between these two, choices 1 and 2, which one will get us proportional sides, proportional corresponding sides. Okay, or sides that have the same ratio. So, let's see, just take a guess here. Let's say it's 9 and 12. Okay, we're going to say 6 is to 9 as 8 is to 12. And it's question mark. And what we're looking to do is, are the cross products the same? If they are, then that's going to be the 1. Okay, let's just show the other one's not going to work. Okay, so if for a moment we get rid of those, let's say we try 8 there, 10 there. Okay, 6 is to 8 as 8 is to 10. It's a question mark. Check out the cross products. 6 times 10, 8 times 8. What we're going to get is 60 is not equal to 64. And that's why that one doesn't work. It's not proportional sides because the cross products are not equal. All right, tricky problem to manage here. What I did with this one is the ratio of the diameters is 9.5 to 2.5. Oops, 2.5. So I played around with some different ideas. What I ultimately came to was I tried to start out as a fraction, and I went ahead and divided this, and it actually does work. If I take 2.5 out of here, divide it out, it's 3.8. Okay. And it's 2.5 times 1. So those knock each other out. So back to this. Yeah, so the 2.5s knock out. Basically what we have is the ratio of the diameters is 3.8 to 1. Now, when you're talking a one-dimensional measurement such as perimeter or length of a side or a diameter, like in this case, you know, you can get the ratio of those two sides, and to kind of use it in the volume, you know, to get the ratio of the volumes. The volume is three-dimensional. Okay, so we'll talk about that. Diameter is a one-dimensional measurement. Okay, it's got a distance or a length only, no width. But a volume, it's three-dimensional. So to move from a one-dimensional to a three-dimensional figure, you're going to take that 3.8 over 1, and you're going to cube that ratio. Okay, so that's how the relationship would work. If it was an area or a surface area problem, you would be squaring it. So that's going to be the relationship. And when you cube this, it's going to go to 54.872 to 1. So it's going to be about 55 times greater. Now, of course, there's other ways we could do it. We could go through and find the entire volume of both basketballs, and then, you know, figure it out from there. But really the problem is, do you understand that concept right here? That the three-dimensional measurement, you would take the ratio of a one-dimensional measurement and cube it. So That's one way to do that problem. That's the intended way to do that problem. All right, so for 15, let's see, we'll go to, it's going to be, I think, a distance problem. Let's just call that A and this B. All right, so if we want that distance, we have a small right triangle here. Okay, so what we have is 3 squared plus 1 squared equals d squared. And one segment would be square root of 10. Now, pentagon, you're supposed to know it's 5-sided. So we'll take the square root of 10 and multiply by 5. So we get 5 square roots of 10. All right, next, let's see. Looking at measure of angle A, let's put a theta right there. Okay, so this is a regular, just straightforward trig problem. What we'll do is we'll label the sides relative to that angle. Of course, this is the hypotenuse, opposite the right angle. All right, so we write down our acronym that helps us remember which trig function defines which ratio of two sides. So looking to me like we're going to use cosine because it's adjacent hypotenuse. So cosine of the missing angle, it's going to have the ratio of 9 to 14. I tend to like to just type that in the calculator. 9 divided by 14 is 0.6429. There's a whole bunch of stuff afterwards. Now, this is kind of a pet peeve of mine. We got to know that we're performing what's called inverse operations. Basically, to get rid of cosine, we have to take cosine inverse of both sides. So to do this the right way, to confuse less students, keep things balanced, all that good stuff is, we shouldn't just write down all of a sudden this cos inverse. It comes from the fact that cos inverse and cosine are inverse functions. So they basically will knock each other out, and we'll be left with theta over here, which is what we wanted. We wanted theta by itself, but we have to do it the right way. Okay. Now we type this in, cosine inverse of this. Make sure you're in degree mode in your calculator, and it gets about 49.99, all that. Nearest degree, you're going to go 50. All right. This is a completing the square problem. And the way I like to do this is I like to put in a space. This is a number. Whatever we need here, that is what we are going to use to complete that square. We're going to do the same thing over here, 4y plus something to complete that perfect square. Now, of course, whatever you add to the left side, we're going to add the same amount to the right side. Now, I skip ahead. Kind of, we pick up on the pattern here. This is going to, the perfect square is going to be x plus 3 squared. So 3 squared is 9. That's what we're missing to complete this square. So we got to make sure that we put the 9 over there as well. This is going to be x minus 2 squared. So negative 2 squared is 4. I'm missing a 4 over there. Keep the plus sign. Add these together, and it's 36. And now what we have is a center. Okay, whatever makes these 0. Whoops. Sorry, that was a y there. This is negative 3, 2. And radius is going to be from the, r squared is right here. That's 36. So we square root both sides, and we get r is 6. Okay. And we're looking at choice 4 here. All right. Continue. All right. Now it looks like we're just going to have to graph this. So r is at negative 2, negative 3. 8, 2. and 4, 5. All right, so RST. Okay. All right, it's got a shot here at being a right triangle, I guess. But we're going to have to do some kind of math to prove it. You know, we might have a right angle there. I doubt that we have one at either R or S. So to do this, we could either take a look at the slopes or the distances. I'm going to go with slopes. Let's try RT first. And you could either do this algebraically or graphically. I got a 6 across, 8 up and down. Let's make sure that looks right from the coordinates. R to T. Yeah, that looks like 6 across, 8 up and down. Perfect. All right, so the slope is going to be rise over run, and it's positive. We'll leave that alone. We might have to reduce it, might not. TS. It's a 3 up and down. Looks like a 4 across if I go far enough. And so that ST, we're going to get a slope of negative 4/3. So come up here. That can reduce. We can take out a 2 from both of them. And whoops, something happened. Oh, I've got this one upside down. Sorry about that. I don't have rise over run. I've got that flipped. So the rise is 3. That should be the top number. Run is 4. And since it's going down as we move left to right, it's negative. Now these two slopes right here are negative reciprocals. Now that, of course, is going to give us a right angle there. And so now we can say that RST is a right triangle. Can't be obtuse because we can't have an obtuse angle in there as well. And we need 60-degree angles, all of them, so it can't be equiangular. We've got a right triangle. All right, let's see. Okay, so we have next a, well, that's not a density problem, is it? A little bit. Okay. Yeah, that's a density. All right. So think of density kind of as stuff over space. That's kind of how we look at it. So we'll have to get, it looks like the space. Okay, we'll have to calculate the space. We'll have, they give us the density, so we'll be solving for how much, you know, stuff there is. What's the weight, right? So let's see. It's a sphere. Radius of 4 inches. Okay. So the volume of a sphere, if we look at the front sheet, the formula sheet, they give us this formula for the volume of the sphere, 4/3 pi r cubed. Okay. So we'll say 4 divided by 3 times pi times 4 cubed. Go ahead and type that in your calculator, and we'll get, I've got 268.083. Keep that in your calculator. Now, I like to use proportions on this. Everybody's got their own way. So I'm going to take, whoops, it's 0.075. Be careful. Pounds to every 1 cubic inch. Okay. And we just figured out how many cubic inches, so we'll put that underneath. 268.083 cubic inches. And we'll figure out how many pounds that is in a minute. So cross multiply, we'll get x equals whatever 0.075 times that is. And we come up with about 20.06. All right, to the nearest pound, we're looking at 20. All right, similarity of triangle BOY. Okay, so we've got 2 similar triangles. And I think they're trying to say the ratio of the sides is 1 to 2. All right, now BO, right, that's the side on the smaller. So I think what we're going to do is, again, proportions are my favorite for this type of problem. So I'm going to say, all right, the ratio of BOY to GRL is 1 to 2. So take a side off of this, right? So we're going to put that on top. And underneath we'll put GR. Yeah, that's the corresponding side. So we can put 3x minus 1 right underneath there. Parentheses are implied. They just won't appear. So I'll go ahead and put them there so that when we calculate the cross products, we've got to be really careful to distribute. Real common mistake right there is to not have a 6. You know, to have a 3 there. Make sure we distribute. Now let's show our work, do some nice things with the algebra. And you get x is 7. Of course, that's not the answer. All right, they want the length of GR. So we've got to plug that back in. And please be careful to, you know, not choose choice 2 just because it looks like it's right. You know, we've got to make sure we finish the problem, read carefully, all that. All right, so we've got chords, tangent, okay, radius, all right, an inscribed angle, and a semicircle. All right, here's what we have. We have a semicircle right here. Okay, any angle inscribed there, right there, angle C, has to be a right angle. There's another reason, you know, you've got this inscribed angle is opening up to a semicircle. Again, so that relationship is half, so 180 divided by 2 is 90. So yeah, angle DCB is your right angle. Which one is she referring to? Let's see, is that a choice? Angle DCB, right there. Okay, so look for that. Okay, any circle, we'll just isolate that. If you've got a diameter, you'll know that by if it hits the center point. You know, if you've got a chord that hits the center point, it's a diameter. It wouldn't matter where C was. Okay, you could put C anywhere on this arc, semicircle, and you're going to end up with a right angle there. Okay, so we got to make sure we remember that one. All right, 22. Okay. Interesting. All right. So it looks to me like, you know, they're trying to get this relationship going. Okay. The relationship here with these three. Let's just test a couple out to show you what I'm talking about here. If this is 2 and this is 36, what they're trying to ask is this going to produce 6 square roots of 2. Okay? Now the relationship here is 2 is to 6 square root of 2. Actually, you know what? We'll call it x. Let's call it x there. Let's pretend we don't know it and see if it turns out to be 6 square roots of 2. So we'll call it x. All right, so it's 2 is to x as x is to 36. Cross products. All right. Now when we take the square root of 72, we can simplify that in this way. Okay, that's simplifying square roots. And, you know, you're looking for a perfect square. The biggest one possible is 36. And it does turn into 6 square root of 2. Now, basically what we've just learned is the answer to this problem is going to be, do these two multiply to 72? Does AD times DB equal 72 or not? If it does, that problem is going to produce an altitude that measures 6 square root of 2. All right, so this one is, we want the one that's not, AD times, let's see, AD dB. So let's test that out. Does 6 times 12, we'll check out this one, equals 72? The answer is yes. That's out. All right, a little trick here. They gave us AB. So really we have 2 from A to D, and we have 22 from D to B. So is 2 times 22, is that equal to 72? I'm sorry, 3. Let me start over on that one. Sorry, they gave us 3 here. They give us 3. And then 24 minus 3 is 21. All right, so let's get rid of that one. Is 3 times 21 equal to 72? The answer is going to be no. So it's a little bit of a trick there they were looking to get you on. All right, so next one. Let's see, 23. All right. Let's see. Okay, circular necklaces. Circular necklaces. Now, radius is 10. And, okay. How many can we make? Same units of measure. Just got to check that. They're both centimeters. All right, so this looks like it's going to be a circumference problem. So, the circumference of a circle is 2 pi r or pi d, whichever one you want to teach. And so that's 20 pi. That's got to be, let's see, 62.83. All right, keep that in your calculator. And now you've got 1,000 centimeters of wire. Now all right, let's do it this way. One necklace is 62.83 centimeters of wire. How many necklaces for 1,000 centimeters of wire? So I try to do everything in proportions when I can, just so it's one method. Of course, there's other ways to do it. If you know right away that all you're going to do is divide by 62.83, just go ahead and do that. But I'm trying to give a method that always is reliable, and so that's why we do it this way. And then we're going to divide by 62.83. And we get, it looks like 15.91. Now this is kind of tricky. You can't make the 16th necklace. You know, if you rounded this, it would be 16, but you got to think, I can't make the 16th necklace. It'll be too short. So really, you can only make 15. You know, unless you get a longer piece of wire, but we just don't have it. So you really got to stop at 15. I think most students are going to do this problem right. The problem is they're going to round and not realize what kind of problem it is. So hopefully don't fall for that. Let's get that right. Okay, 24 is a favorite. It seems like this one's coming up quite a bit. Pretty reliable. What they're doing is, instead of having our similar triangles where this is parallel, they're kind of, I don't know if you want to say it this way, but they're kind of flipping this triangle so that this angle is down here instead, you know. So they're really messing with you a little bit. We got to be careful. So let's make sure that we read this carefully and we aren't fooled by, you know, some of these tricks. Okay. So we'll go through, and it says TU is 4, OU is 5, OC is 7. You're going to want to add those together, okay, to make it 12. And they want to know the length of ST, but really, this is x plus 4. All right. Where's the other information? Okay, angle C is congruent to angle OTU, that right there. So you see where we get that. See, normally when they're parallel, when you have one triangle inside the other, those are the same. What they do? Well, they flip this figure so that these are the same. Now, of course, angle U is congruent to itself. So we do have similar triangles, but we got to be really careful here. Okay. So I'm going to just write this down. Triangle SCU is similar. Now we got to be careful. It's actually similar to triangle OTU. Okay, C and T are the matching angles, not C and O. So with our proportion, let's see. We've got SU is to, what's its corresponding? OU. And, all right, we've got CU. That should be corresponding to TU. So let's see if we can get some replacements here. X plus 4 is to 5, as 12 is to 4. So cross multiply. 4x plus 16 equals 60. And let's just go ahead and quickly finish this algebra. All right, we get x is 11. But let's see, yes, that's what we wanted. We did want x, so ST is 11. Be really careful on the matchups, okay? You would think you'd have 12 over 5, you know, but that's not how it works when they flip this figure. It's 12 corresponds to 4. 12 does not correspond to 5, so you got to be really careful in this setup. That's why this similarity statement really saves you on some problems like this. Hope this was helpful, and the next video will have the open response.